The instinct to build a home is a fundamental trait shared by all living creatures, from the most complex mammals to the tiniest insects. Yet, despite man's remarkable capacity for innovation, the core principles of home construction haven't changed since the Middle Ages. It's astonishing that we, as a civilization defined by progress, have not revolutionized the way we construct our homes to become more cost-effective. However, the future of housing is on the brink of a radical transformation. With a growing number of companies embracing 3D printing technology, the traditional methods of home construction are about to become obsolete. In this video, we'll have a look at how rapidly 3D printed houses are becoming the new normal and the way we live and build is about to change forever. The building blocks of 3D homes. Before discussing the recent developments in the world of 3D printing, it's time for a history lesson. Contrary to what many people think, the seeds of 3D printing were sown in 1939 when William E. Herschel created the world's first 3D printed concrete building in Indiana, USA. His innovative wall building machine employed an automatic ramming mechanism to compress concrete between spinning discs, forming solid layers. This groundbreaking invention pioneered the concept of additive manufacturing, better known as 3D printing. Recognizing the potential for his invention, Herschel swiftly filed patents for his wall building machine just a year later, and his vision extended beyond single-story structures, encompassing multi-story buildings and even self-supporting domes, all fabricated using this groundbreaking method. While Herschel's work laid the foundation, it was actually the development of inkjet printing technology in 1976 that was a pivotal moment. Both inkjet printing and 3D printing share a fundamental principle: depositing material in precise layers under digital control. This technological advancement later influenced the evolution of 3D printing beyond its early concrete roots. However, the real turning point in the evolution of 3D printing came in 1981 when Hideo Kodama, a Japanese researcher, broke new ground by experimenting with materials beyond ink. His work led to the development of two groundbreaking techniques based on photo-hardening plastic polymers. Interestingly, one of the earliest applications of 3D printing technology was in architecture itself. During the 1980s, firms began using it to create tabletop-scale models, a more cost-effective and efficient alternative to traditional handmade replicas. In 1984, American engineer Chuck Hull, a visionary who would later co-found 3D Systems, came into the picture and introduced stereolithography. This revolutionary process used a UV laser to solidify liquid photopolymer layer by layer, transforming digital designs into tangible 3D objects. Hull even developed the STL file format, which remains the industry standard even today. Building on the success of SLA, Hull also unveiled the first commercial SLA 3D printer in 1988. And a year later, Scott Trump patented fused deposition modeling, a technique that extrudes melted plastic layer by layer, making 3D printing more accessible to a wider audience. In 1992, 3D Systems launched SLA printers commercially, offering a practical way to create complex 3D objects overnight. While not perfect, this technology marked a significant leap forward. The 90s also witnessed the exploration of 3D printing for larger-scale projects. Stratasys also entered the market with commercial FDM printers, expanding options for consumers and industries. MIT researchers contributed to the field by developing their own patented 3D printing system as well. Their system enabled the creation of objects using various materials, including plastic, ceramic, and metal under the guidance of CAD software. 100 homes printed. Fast forward to 2024, and there is a whole community of 100 3D printed homes rapidly taking shape in the Texas Hill Country. Located in Georgetown and developed by Icon, Lennar, and BIG-Bjarke Ingels Group, Wolf Ranch is redefining the future of house construction. Situated along the San Gabriel River, these innovative homes, part of the Genesis collection, combine cutting-edge technology with sustainable design. They feature 8 floor plans and 24 distinct elevations, and the 3 and 4 bedroom homes range from 1,500 to over 2,100 square feet. The best part is that each home is equipped with rooftop solar panels in order to reduce the environmental impact. Wolf Ranch in particular was chosen for 3D printing because it's an opportunity to showcase the technology's potential to save time and money, reduce waste, and create innovative homes. With construction almost in its final stages, built entirely with 3D printing technology by Icon, it has been reported that over 95 homes have already been printed, and over a quarter of them have found new owners. The Genesis Collection isn't the only residential construction project of Icon. From the experimental House Zero to the Shicon House, these projects represent different approaches to utilizing 3D printing in the housing sector. Other notable projects include El Cosmico, East 17th Street Residences, and Community First Village, 3D printed homes in Nicojuca, Mexico with New Story. Each project offers unique insights into the potential of 3D printing to revolutionize the construction industry. The future of housing is here. But that's not the coolest part. It's Icon's massive Vulcan printer, which is 45 foot wide and weighs 4.75 tons and emits a concrete-based material layer by layer to create the homes' sturdy walls, which, as a result, reduces construction time and minimizes waste. The resulting homes are not only faster to build, but also boast superior insulation and resistance to weather, pests, and mold. The printer is designed as such to be quickly transported from site to site, and it prints directly on the ground or a poured slab. The printers use a special building material called Carbon X, which is mixed by another machine called Magma, and the whole process is controlled by the Build OS software suite that turns digital house plans into real homes. A game changer for construction. One of the most compelling advantages of 3D printing is speed because, unlike traditional building methods that can take months or even years, 3D printing can produce entire structures in a matter of days. Beyond speed, sustainability is another key benefit. 3D printing minimizes waste by using only the necessary materials, resulting in a reduced environmental impact. Additionally, the technology can incorporate recycled or sustainable materials, further enhancing its eco-friendliness. Design flexibility is another hallmark of 3D printing, as it allows architects and engineers to explore intricate and complex forms that would have been impractical with traditional methods. 3D printing also ensures that structures can be built to exact specifications, ensuring accuracy and quality, and now, with the integration of artificial intelligence, there are even more possibilities to optimize designs, predict material usage, and control the printing process, leading to more efficient and cost-effective construction. The reality check. However, while these homes offer numerous advantages including cost efficiency and durability, one unexpected challenge has emerged. The thick concrete walls can interfere with wireless signals, forcing the residents to opt for mesh Wi-Fi systems to ensure reliable connectivity throughout their homes. This technology could be a game changer for places like Maine, which faces a severe housing shortage. The state needs around 80,000 new homes by 2030, and 3D printing could help address this crisis rapidly and efficiently. While these 3D printed houses sound like a dream, the price tag on them would make any normal buyer nervous. They're priced competitively at $470,000 to nearly $600,000, making them affordable but only for people with a specific level of income. And with these prices, questions like could 3D printed homes help address global housing shortages and homelessness can be answered pretty easily. When compared to traditionally built houses, there is a huge difference in cost. It costs around $325,000 for a newly constructed entry-level home in Texas, typically ranging from 1,600 to 1,700 square feet, while the same can't be said about the 3D printed houses in Wolf Ranch. Outro. While these 3D printed houses represent a significant leap forward in construction technology, their current costs put them out of reach for many. As technology matures and production scales, it's anticipated that the cost of 3D printed homes will decrease, making them more accessible to the broader population. This potential for cost reduction, combined with the numerous advantages of this construction method, positions 3D printed housing as a promising solution to address global housing challenges in the future. Let us know your thoughts in the comments. Will 3D printed homes finally be the answer to the government's woes of ending homelessness? And don't forget to like, share, and subscribe for more.